Hello students, welcome back to our channel. So students, in this video we are going to study a very important topic from vectors, and that topic is the addition of vectors. This topic will be studied in class 11th physics and in class 12th mathematics. In both these classes you are going to study this topic and it will be used in every other topic related to vectors. So it is very important. What is the meaning of addition? By addition of two vectors or more than two vectors, we simply mean that we are going to find a vector which is the resultant of the two vectors or more than two vectors. What is a resultant vector? A resultant vector is a vector which has same effect as all the vectors combined, whose resultant is this vector. For example, let us take a very simple situation. Let us say we have two vectors in this situation, and one vector is force vector which is acting along this in this direction, and second one is also force which is acting along in this direction, that is opposite to the first one. This vector has a magnitude of 50 Newton and this vector has a magnitude of 30 Newton. Then you will say that the net effect, we can say that the net effect or the combined effect of these two vectors is simply 20 Newton force in this direction, because if one person is applying a force of 50 Newton from this direction and the other one is applying a force of 30 Newton from the opposite direction, so the net force will become 20 Newton and the net force will act in this direction and the magnitude of the force is 20 Newton. So this net force has the same magnitude or it has the same effect as both these vectors in combination are producing. So this vector is called the resultant of these two vectors. So it simply comes by the addition of two vectors. That is what we are going to study. But here you will say that we have not added these two vectors, you will say that we have subtracted these two vectors. So why we are calling it addition of two vectors? Because if you simply add 50 and 30, then you are doing it wrong, because since these two are vectors, so we have to take the directions into considerations, and if we take the direction into consideration, we will put the actual sign, the correct sign before adding. Since these two have opposite directions, so we have to give them different signs. So if you take this direction as positive direction and you take this direction as negative direction, that is entirely up to us that which is the direction that we want to take as positive and which is the direction that we want to take as negative. So if I am taking this direction as positive, then this 50 Newton will be taken as plus 50, but this 30 Newton will be taken as minus 30, because it is acting in the direction which we have taken as negative. So now by putting the correct sign, now if we add these two vectors 50 minus 30, then we are going to get 20, right? So this is what the addition of vectors means. But what happens if these two vectors are not acting in opposite directions, they are acting in at 90 degree to each other, or they are acting at 60 degree to each other? So we will simply write both of them in vector form. We will simply write both the vectors in vector form. Suppose the first vector is a1 I cap plus b1 j cap plus c1 k cap, and the second vector is a2 I cap plus b2 j cap plus c2 k cap. So if we write both the vectors in vector form, then direction doesn't matter, because directions have already been included in this form. When you are writing it in this form, obviously you are including directions also. Then to find the resultant of a and b, you will simply add them in vector form, right? If you are dealing with the magnitudes that we were doing just now, if you are dealing with the magnitudes, you have to think that I have to give negative direction to this vector or a positive direction to this vector. Don't go into that. You just write both the vectors in proper IJK form and you simply add them and you will get the resultant vector. For example, let's come back to that situation again. Suppose this is x-axis, right? This is x-axis. So if this is x-axis, then this force of 50 Newton must be written as 50 I cap in vector notation, right? And the other force was 30 Newton, but since it was in this direction, so if we are taking this as x-axis, this must be the negative x-axis. So if this was 30 Newton, so we will write minus I cap sign with it, because if this is negative x direction, then obviously the unit vector along this direction will be minus I cap. So now both the vectors are in vector form simply, and we will add these two vectors now to get the resultant vector. So if we add these two vectors, obviously we are going to get plus 20 I cap. That means I cap means the net force is acting along the positive direction of x-axis, right? Okay, in this case, since it was a simple case, we know that the direction of resultant vector is this direction. But what happens when the two vectors are in any direction, then the resultant of the two vectors is given by the addition of two vectors, and the direction of the vectors is given by a law which is called the triangle law of vector addition. It simply says that if you want to add the two vectors, suppose we have a vector this, and we want to add this vector to suppose this, right? So if you know this in the form of IJK and if you know this in the form of IJK, to find the resultant of the two, you just add the two vectors. Add I वाला term I के साथ, then J वाला J के साथ, then K वाला K के साथ, right? But what about the direction? So we will use triangle law of vector addition to find the direction of the resultant of these two vectors. It says that if the two vectors are taken as two adjacent sides of a triangle in same order. What does that mean? Now you just shift this vector, shift the tail of this vector, we will bring the head too. If you shift the tail of this vector on okay if you shift the tail of any one of the two vectors on the head of the second vector, right? So since if we are changing just the position of the vector, we are not changing the direction of the vector, we are not changing the magnitude of the vector, so we can shift the vector to any position, because we are not changing the magnitude and direction, which are the basic properties of the vector. So we are not changing any property of the vector, we are just changing the position of the vector, which can be done. So to find the direction of the resultant vector, you will just shift the tail of one vector on the head of the other vector, and now a triangle is forming. You will just complete this triangle by drawing the third side, and this is the third side, but you have to draw this side in the opposite order. What are the order that we are talking about? Since we are going in this order, tail, head, so the third side should be, you will draw third side like this, tail, head, tail, head, tail, head, but that is wrong. You have to draw the third side in the opposite order. It is tail, head, then this must be head and this must be the tail. So the resultant vector has this direction, right? So the resultant vector has this direction. So if two vectors can be represented both in magnitude and direction by two adjacent sides of a triangle, taken in same order, then their resultant is represented completely both in magnitude and direction by the third side of the triangle taken in opposite order, right? So these are the two vectors. If we name the vertices of this, let us say this is O, this is A, this is B. So this vector OA, when added to the vector AB, will give you the resultant vector OB. right? So you know how to add the vectors. We are just discussing about the direction. So to find the direction we have to use the triangle law. But what happens when the vectors are more than 2? What happens when there are more than 2 vectors? Then triangle law is extended to something which is called polygon law. So if we have suppose 4 vectors and we have to find the resultant of these 4 vectors, then what we will do? Suppose this is the first vector, and we have a second vector. So you just shift the second vector such that the tail of the second vector lies on the head of the first vector. So this is your second vector. Now take your third vector and again do the same thing. Shift it such that the tail of the third vector is on the head of the second vector, and this is your fourth vector. For this also you are going to do the same thing. Now after putting this arrangement like this, the resultant of all these vectors, a polygon is starting to form, right? So the resultant vector of all these vectors is the last side of the polygon, which is taken in the opposite order, right? Now just join these two to complete the polygon, but break the order. Tail, head, tail, head, tail, head, tail, head. No, this will be head then tail. So this will be the resultant of all the vectors. If we mark the vertices, then we can say, then this vector OD is simply the sum of OA, AB, BC and CD. OA plus AB plus BC plus CD, right? And we write a vector always in this manner. First, that alphabet comes in the name of the vector which is represented by the tail or which is representing the tail, and then comes the head. So this vector is OA, not AO, right? This vector is OA, not AO, or we can write it minus AO, because when we are writing AO, that means we are going in this direction, and obviously if this direction is positive, then this must be negative. So either this is OA or this is minus AO, right? So this is how you can add two vectors. Triangle law is very important in the addition of vectors or whole of the vectors, and polygon law is equally important when you have more than 2 vectors. So prepare all these topics very carefully. I'll meet you in the next lecture. Till then, all the very best.